Right. So let's go over our quiz 2. That first question was finding the domain of a function and then writing it in interval notation. And so whenever we're asked to find the domain of something, what 2 criteria want to pop into your head? We're dealing with fractions. Our denominator can never be equal to, yeah, because it makes it undefined. And then the second requirement is if we're dealing with an even root index, then underneath that root has to be positive or 0. We don't want it to be negative. So no negative numbers under our even root. Lucky for us, that first condition doesn't apply because we're not dealing with a fraction. Exactly. So we just have to hone in on that second requirement, which means our x minus 3, which is underneath that root, has to be what? Exactly, greater than or equal to 0. And now from this stage, we just utilize our knowledge of inverse operations. We add 3 to both sides so that we get x is greater than or equal to 3. From a number line standpoint, are we going to have an open circle or a closed circle at 3? Yeah, because we're including 3. And are we shading to the left or to the right?
To the right.
Good. Now we have to represent this in interval notation. So is it going to be a hard bracket or a soft bracket? Hard bracket, 3, comma, infinity, yeah, parentheses, beautiful. And we're done. That is the results for question 1. Again, you guys all have your quizzes, so if you made a mistake, please mark it up. Try to do it in a different color pen or a marker so that you can really see what mistakes you're making so that you don't make them on future quizzes or future exams. Question 2 was an average rate of change problem, where anytime you see average rate of change, it's really just slope in disguise. It's just you're not necessarily dealing with a linear function. In this case, what type of function do we have? A quadratic. Yeah. And so I'll write the general equation for our average rate of change. Well, color code. It's just the difference between your 2 y values are f of b minus f of a over the difference between your 2 x values, b minus a. And so what do we have here? Our a is 0, our b is 2. And then our f of a, how do we find that? We just have to plug in 0 wherever we see an x. So first, create your parentheses wherever you see your x, and then replace it with 0. So you get your f of a to just be equal to -9. And then it's the same exact concept when we're looking at f of b. The only difference is instead of plugging in 0, we're going to be plugging in 2. Two squared is 4, times 2 is 8. 8 minus 9 gives us our f of b to be -1. And then it's just plugging in all of those numerical values into your formula to get your final results. Our f of b minus f of a all over b minus a. We have -1 minus -9 all over 2 minus 0. Two negatives next to each other give you a positive. And so you end up with 8 in the numerator, 2 in the denominator, which ends up being 4 simplified. We're done. Any questions on the first page? No. Right, let's move on to question 3, where we're given a graphical representation of a function, and we're asked to find the domain and range. Now, this function doesn't go on forever. We have specific endpoints, and that's important to keep in mind because when we're looking at our domain, we're going to have hard brackets on both sides because we're including those endpoints. So domain, all of our possible x values. What is the smallest x value possible? Yeah, when x is equal to 0, and we're including 0, so once again, it's a hard bracket. And then what is our largest x value possible? 4 pi, excellent. So our domain is just 0, 4 pi, hard brackets on both sides. Our range, what is our lowest possible y value? -4, once again, including that -4. And what is our highest? Yeah, +4. Once again, hard brackets. And that's it. Question 3 was probably the fastest problem to solve on this quiz. Everyone moving forward especially should get these types of questions right on assessments. It's just being able to read a graph properly. And then last but not least, this was probably the longer question to answer, being able to sketch out a piecewise function. So first, straight off the bat, with any graph, you always want to label your x and y axes. You want to give a proper scale. Seems tedious, but it really doesn't take you more than 20 seconds to complete the scale and the axes. And then once we sketch out the graphs, your last part is to properly label the graph by its function name. But we don't have to do that until our very last step. So what are we looking at? We're looking at 2 different types of functions pieced together to create an entire function in itself. And that first part is our constant function at y is equal to 1. Is this what type of line is it? Horizontal or vertical? It's a nice horizontal line. And then our second, we have x plus 1, which is famous linear function, which has a y-intercept at 1, and then a slope of 1, up 1 over 1, up 1 over 1. Excellent. This right-hand information is really crucial because that tells us that turning point, that break between the 2 separate functions. So at x equals 1, and I'll actually explicitly highlight this on the graph, but at x equals 1, that's where those 2 functions meet each other. That's where you're going to have a point where it's included for one of the functions, that top one, because 1 is included, so closed circle. And then it's also going to have an open circle known as a hole for that bottom function because we're not including 1 for this x plus 1 function. Let's now look at how to graph that top function. So I'm also just going to maybe label this green line as x equals 1. But f of x equals 1, we know we're including that point on the green line, and then everything to the left. And if it's a horizontal line, it's just all values when our y is 1. So we essentially just have horizontal line shooting to negative infinity for our x values. Now on this right-hand side, first we want to evaluate what is our function when x does equal 1, because that gives us the whole. So we just plug in 1 for x and we get 2. So 1 comma 2 is where we're going to have a whole. And then, you know our slope is positive 1, so we just go up 1 to the right 1. You can go to the end of the graph, or you can just plot a few points and then just connect the points to create your line. There we have it. So last but not least, you want to label this piecewise function. We have 1 when our x is less than or equal to 1, and then we have x plus 1 when x is greater than 1. And we're done. Full credit. So I will say I won't be too picky on this quiz with labeling the function. I will take points off if you didn't label the x and y axes and put in a scale. But moving forward, if you don't label the function and label your axes, I will take some more points off. So you always, always, always should label them. Any questions? I'm gonna stop recording.